Hi, my name's Tom. I talk about code. Welcome to another Rust programming livestream. Today, we're picking up where the last stream left off, partway through implementing string literals, and we hit this problem where string literals, they need to go somewhere in our actual binary, right? So let's say we have a file, some file on our computer. It has some stuff in it, some data in it. We want to load this into our computer's memory, into our computer somewhere, and we want it. Computers don't look like this anymore, that's okay. We want to load it into our computer somewhere and have it execute, right? Some random file somewhere from somewhere on a hard drive. Currently, when you look at these blobs, this binary that we're trying to load, it's just a set of instructions. It'll be like an add something, it'll be a store something, ... right? That's it. It's just the raw instructions. We load it into address 0 and we go. Sometimes we leave a little bit of padding for global variables, but usually we just smash a bunch of code and then execute it. Now, it turns out that binary files are usually a bit more complicated than this, right? If you've ever looked at ELF files in Linux, they're really, really complicated. They have a lot of stuff in them. We don't want to use a format as complicated as ELF, but I have outgrown the effectiveness of just doing this. So today, we're going to define a binary format that's going to allow us to handle static data, and then we're going to hopefully be able to check off string literals at some point today. That's the goal. That's the goal. Bobius, hello, welcome. Pingu, EXOR, welcome. How's it going? It's going well. It's going well. This is going to be a good stream. This is something I've been putting off for way too long, so I'm really excited to finally get in and do it. Now, let's quickly just review yesterday's very similar looking notes, okay? Because I was talking about this stuff, I was talking about where static data should live, I basically came up with another way I could do this without a binary format, but the more I thought about this overnight, the more I thought that I just need to end up with a binary format. So we're going to jump in and do that. What compiler I'm building? This is a compiler for my own C-like programming language, all built in Rust. So, we can have a look at how it goes at the moment. Let me pull up. It's still here. This is exactly as I left it yesterday, which is great. So yeah, yesterday we started putting strings at the start of our program. So it's kind of like we have this offset. This is where our code starts executing. But before that, we can just smash some strings in and reference them. So if we look at the program that this compiled from, it looks a lot like C. It looks a lot like C. It's not C, but it looks like C. There's a couple of subtle differences, a couple of opinionated things that I've changed that I think are really cool. And this is targeting my own 16-bit virtual machine, so that's another layer of why I'm not using standard tools and doing everything myself. So the problem is, in our code gen, we have this offset somewhere, program start offset. We look at this program offset. Currently, because we're doing globals, we can look at all the globals ahead of time. They're defined outside of functions. So before we start compiling functions, we can work out how far our program needs to be offset, and then we place all of our functions according to those offsets. Now, having a binary format does not fully solve this. Having a binary format doesn't fully solve it. It makes it a little bit easier for me to communicate this information back up, because at the moment there's a rat's nest of referencing various parts of the context. So we're going to do this in two parts. And I think the first part is to just bite the bullet and do this binary format work. I think this is going to be the most kind of fun thing to do right now. And we're going to put this in our VM crate. This is going to be exported to WASM, so WASM is going to be able to pull this in and load these binaries, parse these binaries. I want it to play nice with the ecosystem, and I want it to be part of the very core crate. So this isn't actually part of the programming language, this is more fundamentally part of the virtual machine. Awesome, so I've said this word a few times, binary format. And what does a binary format need to do, right? What are the goals making a binary format? Well, we're going to have various bits of data in our binary. So again, let's imagine we have some file, right? And when I say file here, what I really mean is a stream of bytes, but I'm going to call it a file. So we have some data in here. This data has to go into RAM, and it has to tell us where to put the program counter or the instruction pointer, right? Where do we start executing this program? So AKA entry point. So it has to say where in RAM it's going to go. It has to say where does this start executing. We also might want some debug info, but this is less important. Okay. Now, we have this really good benefit that our code, it only does absolute jumps to go to functions. And so we probably could do some fun relocatable stuff, right? We probably could compile code that could load into any address, but we're not going to do that. We're gonna compile code that expects all of the functions to have known addresses ahead of time. This is restrictive, and defining a binary format's a step towards not always needing that, but it's too complicated to not do this. So basically, we have 3 pieces of information we want. Right? So the first thing, how do we load it into memory? Well, we're going to define something called a section. And a section is going to say that some number of bytes go from, let's say, from file offset to address, right? So from some arbitrary part in this file, copy a number of bytes to some target location in memory. This is the heart and soul of a binary format. Copy the stuff into memory, and then let's call this like metadata, right? Is it metadata, or is it like, I guess in a sense it is, right? Yeah, let's call it metadata. We're going to have some data about the data that we've loaded, right? So we're going to want some kind of versioning. Versioning is going to be important. We're going to have an entry point. I'm going to include something called hardware. I'm going to call it hardware config flags. This will basically say that the compiler expects certain hardware interfaces to be available. This will be unused for now, but we're going to put it in there because I think it's going to be important important later. Bobia says data about data is in fact metadata. Exactly. I don't think anyone's going to gripe on, why does this, I keep saying don't show this again. And this, oh, hold on. That window didn't show up. It's over here. Data about data is in fact metadata. Exactly. You can't tell me that's not metadata. You can't. Illegal. Relocation data can be added later. Exactly. If we build our format smart, then we will always have room to add more stuff like that later. That's good, always good news. Always good news. Okay, so we'll have some metadata. This metadata is also actually going to have to explain what are the sections? Where do the sections go? Things like number of sections. Okay, and then we have one other thing, which is debug info. And right now, the only debug information we actually use is this. We have a list of symbols. So let's say list, and it's a pair: symbol, address. And this means we can annotate the compiled binary in our memory view with actual symbols that represent, like you can see that this is where the main function starts. So that's really useful. So this is good. And so then we also need, let's call it debug metadata. And we don't know what this is yet. This is undefined. This is to be defined. So we've got 3 things we want to put in this file. So how do we start it? What does that file probably look like? Well, the first thing we're going to want is some kind of header that's going to contain all of this. So let's write a quick specification. Let's say header. It's going to have an int 16. Let's call it an I6. Let's call it a U16 for version. It'd be fun to actually define this in the language, like have those structs defined in the language. That would be cool. We're not going to do that. I don't think that makes much sense, but it would be cool. So we're going to have a version. They're going to be 16-bit numbers because everything's 16-bit. And I think 16-bit, we may as well commit to that. The entry point is also going to be a U16. The entry point has to be in the 0 page. We're going to enforce that restriction. It's always in the 0 page. We have the 32-bit address space, but it's paged. Entry point has to be in the 0 page, only 16 bits. Hardware config. We'll make this maybe 4. We'll maybe say U16. Maybe let's just go with 4 numbers. We'll call it hwconf. And it'll be unused. And maybe we won't use all of these numbers, but at least it's got forward compatibility, number of sections. This can be a U16 as well. If you want more than 65,000 sections, I've got a problem with you. You're not using my language right. Section count. And then we also want some debug metadata. Now, let's put, let's maybe leave, let's say 6 words of debug unused, right? Things that we might add in the future for debug reasons. We could, I guess, just actually call it unused and leave space for debugging in the future. Okay, and ELF actually has a bit of this. If you ever look at an ELF file, the headers still, to this day, I believe, have fields that aren't used because they put them there just in case they were going to be useful in the future. Because you never know. You never know. Okay, so this does it. So sections, right? Immediately after the header, you have end sections. So these, yeah, this is good. This is good. So a section is just 3 numbers, right? It's a U16 num bytes, or let's call it size. It's gonna take a it's gonna be maybe, do we want a U32? How big is this file gonna be? Let's make it a U32. Offset, this is the offset inside the file. Maybe this is actually a usize, I don't know. And then we're gonna take a U32, which is the address to load it to. Awesome, so there's gonna be n of these after the header, right? So we'll have header, and then section 0, section 1, ... So this is kind of our like header info, and then there's some arbitrary data that the sections reference. Awesome, awesome. And this is our complete file. This is it. This is what our binary is gonna look like. So that feels like a real specification. I think we can build this. I think we can build it. Does this feel good? I'm feeling good about it. I'm feeling good about it. So let's go into our VM. Let's make a new crate. Make a new directory in our VM. Source. Need an exclamation mark. Let's swap to the right scene. VM source. We'll call this bin. Oh no, we won't. We can't call it bin because that's for executables. We'll call it binfmt, I guess, for binary format. That makes sense. Okay, so apparently you're not meant to name files like this anymore. Weirdly, I thought you were meant to call them. I thought you were meant to do this like directory/mod.rs. Apparently, Clippy says to just do source binfmt.rs and then have a directory as well. Anyway, neither here nor there. That's something to think about in the future. Let's define these structs. So let's say struct header. We're gonna have a U16 version entry point hardware conf section count unused. Entry point U6. Now we want. Wait, hold on. My brain broke. This is the hard thing when you look at when you're writing. Where's a good test? Struct. It breaks your brain when you write code like this and then you go back to Rust and you have to think about structs in like the right format. Also, if I look at my context, what am I actually... I'm using usize a little bit here, right? And this is weird because I have this edge between my code in the outside world, everything inside my code should be a U32 or a U16. So a symbol should use a U32 for an address, right? But if I'm referencing an offset in a file, that probably should be a usize, but also usize is platform dependent, and this is a binary format specification. So I need to use an exact integer width. I have to be explicit. So we take a version, we take an entry point, which is a U16 as well. Let's call it entry point. We have a hardware config, which is going to be an array of U16. There's going to be 4 of them. We're going to have... I'm actually going to call it hardware conf, just to give it a more weird name. I think that's cooler. I think that feels more like a real binary format. We're going to have section... We'll call it section count. I think that's clearer than sections. That can be a U16 as well. And then we'll have unused, which is going to be a U16. It's going to be 6 of them. Cool. Now, what's the best way to serialize and deserialize this? Do I just write my own little jank function, or do I use cert? I'm actually going to write my own little jank function. I think that's going to be important. I really want to minimize dependencies because this is getting compiled to WASM. It's currently a 120 kilobyte WASM blob for the virtual machine. I don't want to add too much weight to that. So then we're also going to have a section. Now this is actually like the bits. There's probably yeah, we'll go like this. We'll call it a section def. We'll call it a section for now. It's going to have a size, which is going to be a U16. It's going to have a file offset, which is going to be a U32, and it's going to have a address, which is going to be a U32. And this is it. This is all we need. Then there's also going to be, you know, a binary file, right? Like a struct, which is the parsed version of this, which is also going to have a version. It's going to have an entry point. These fields are all pub, by the way. These are just plain data structs. They're not going to have any methods. The idea of a pub unused field is very funny. And maybe, in fact, this should not be pub. Cool. And then the actual binary file is going to be a little bit more... oh, I've made a typo. Thank you, Bobius. Saving the day. This is what I need. You know, some people use AI for this. I think this is much better. I think this makes way more sense. All right, awesome. And then instead of having this like spelled out, so maybe we still have a hardware conf. Maybe we won't actually use that for now, but then we'll have like sections, which will be a vec of section, instead of having to, you know, have this like indirection, I guess. So this is the difference between how it's represented on the wire and when we actually use it. Cool. Oh, and then hold on, there's the other part where we actually have the file data, which is maybe just going to be like a vec of U8 or something, like all the random garbage we read from the file. So then we could say binary file, we could have a function, we could say load to VM, which will take a reference to ourself and a machine, a mutable ref to a machine, and all we say is for section in self.sec. So for each section, we want to read the offset of this file. So that's the offset within this data vec. And again, this is this thing. There's got to be a Rust function that copies a subset of a vector to another vector to somewhere else. Maybe not. I guess I just get like a sub slice. Like, can I take a sub string, a sub vector, and as a copy? Because then I can map that into the VM directly, and I need to double check what the ownership is when I do that. So in memory.rs, map addressable. Oh, it's not here, is it? It's vm.rs map. Yeah, map and addressable. So we map memory, map an addressable, memory mapper. This is like a higher level one. Linear memory. Yeah, so we have memory backed by an array. Backed by a vec, sorry. Now, surely I know this exists, bin VM, because I map program into this. Memory mapped buffer, that's what it's called. Where does that come from? Simple VM. Where does memory mapped buffer come from? io.rs. That actually makes a lot of sense. Memory map buffer. Okay. Extend from slice, that only adds to it. Yeah, this isn't quite what I want. I was looking at this last night. This is close to what I want. And actually, I'm not going to put them into another vec. Well, I don't know. There's two ways to do it. One way is to build a vec and then map that into memory. I guess it's actually smarter to use this interface that I've already built. And I can just hopefully take some slice. What do I need? It takes a vec. So I guess I can make a slice and then convert that slice to a vec and then use that to build a memory map buffer. This is probably horribly confusing for people that haven't followed this down from the start, but that's okay, because it's all going to come together into something beautiful. So for each section, we want a subset of the data. We want data, we want to go from section, self.data, section.file offset, all the way to section file offset plus section size. I don't know what the failure condition for this is. I think slice creation is pretty loose. We could just get something that's empty. So let's say to do validate. Maybe we can check this by saying if self.data len, if the length is greater than equal to section file offset plus section size, right? If the size is at least big enough to accommodate this slice we want to take. So if it's somehow less than this, then we have an error. Maybe this needs to return a result. Maybe. Yeah, it probably does, right? Because there are ways that this can go wrong. So let's say result. And let's just give back a string for now. This is my favorite prototyping thing to do that I feel like is really bad practice. We'll give back an error. This error is going to say section. For error reporting, let's also get the index of the section. Also my favorite thing to do. And we're going to format section I. Section I goes from here to, so section I has this range in the file, which tries to copy to an address, file out of bounds. Right, this is a slightly cryptic error, but I think it'll be useful. So we have the index of the section. It goes from file offset to section, file offset plus section size, and it goes to section.add. Cool. So we have this early out. If it goes wrong, we have an early out. And because we're doing it in a loop, we can't really do this without a return. Can't really do this without a return. So we read this data. No, we don't. Yeah, so we get this as a slice. Let's say sub data, maybe that makes sense. And then VM map, right? Map it in. Like this. So program length. Yeah, we need to give it an explicit length. So it's the section address. It's the length of the, well, actually it's the section size, right? It's how big the section is, because we know that it's going to be this size because we've verified that the underlying data is big enough for the thing we're trying to slice. That makes sense, that makes sense. So we have this, and then we have a memory mapped buffer, which is backed by sub data to vec. Okay, I think that's good. Now, this returns an error potentially. What does this actually? It's a string. It's a string. We'll fix this one day. Right now it's a string. And that's it. We've loaded all of our sections. We've mapped them into memory. That's cool. That's really cool. Another thing that might be interesting is if we can do read-only. So maybe I'll add something to our sections here. Maybe I'm gonna add, what field? What would it make sense to call this? Mode, right? And we'll make this a U8. We'll have a couple of bits. Let's make it a U16. I'm feeling generous, right? Because this is gonna add up to 4, 8. It's gonna add up to 12 anyway. I don't think having it add up to 11 is really gonna actually save any space. So let's have it add up to a nice round 12. And then we need to look at I/O, right? So memory map buffer. We can write to it. We can write to it. Let's just quickly modify this. This is a side quest. This is a tangent within a tangent within a tangent. Let's just make it a non, what's this called? Like a anonymous field or whatever, an indexed field. Let's say buffer the underlying data, and let's say read only. It's going to be a bool. The default is not to make it read only, but we'll make a copy of this, which is called new read only. So this is going to be simplistic for now. It's going to be very simplistic for now. We're going to have to change a few little things here. Everywhere we reference self.0 will have to become a self.buffer, but it's actually not too hard to do. Self.buffer. And these are just the bare minimums we need to implement to make this an addressable, right? An addressable is anything that can be addressed, that can be mapped into the memory space of our virtual computer. Okay, so now we just need another error case here where we say if, this will become an else if, I guess, if self.read only. So we're going to check this first, right? We're always going to check read only first. We don't care if an address is valid or not. You can try and, if you try and write to address like 9999999 and that's out of bounds, the first thing that's going to trigger is this read only error. I think that makes sense. But this might need changing in the future. This might be counterintuitive, but we're going to try this first. We're going to try this first. And now we might need a new memory error for this. We probably will, right? We're going to call this read only. And that's it. This device is read only. You aren't allowed to write to it. Cool. This, I guess we want the address as well. Cool. Because we want to say what address the read actually failed at, right? That's probably good. Maybe this should be the responsibility of the thing up the chain to report on, but I don't know. I think that does make sense because we can also, like, we can do the translation. This is a translated address. Actually, no, hold on. That's not useful. I'm going to undo it. Because if we try and write, say, hex 1000, the address we get in this function has already gone through a mapper potentially. So either, like, if all we have mapped into memory is this one buffer, then reading and trying to write to it will either all fail or all succeed. If we have a subregion of memory that's mapped into a memory map a memory mapper, right? If we have like address translation, then the address that comes into here will be already translated. It'll be relative to this whole buffer. So again, it will either all succeed or all fail. So it's not really useful to say the address. I hope that makes sense. There's no like protected sub-region of memory. If we were protecting a sub-region of memory, then yeah, we would want the specific address. But this is an all or nothing switch for the whole device. Now again, maybe this should exist in the mapper level. We've really gone on a side quest. Maybe this should exist up here, where we have mapped memory record. Maybe read write, like maybe some of these permissions should exist in the actual record that we do translation on. But I don't think. Well, I think it makes sense here for the actual buffer to have a say in this as well. Okay. That was a big side quest. That was a really big side quest. All that to say is, let's say addressable equals. So if the section mode, let's just say if it's equal to 1, then we'll make it read only. Otherwise, and this is what this whole expression returns, otherwise we give back the version of this that is just new, no read-only. And then this takes the addressable, the thing that we're putting into the address space that we can read and potentially write to. We can always try and write to it, just might fail sometimes. Cool, so we have a binary file, we can load it into a VM. We also now need to be able to load this from just arbitrary bytes. Right, so maybe we want a function for that too, and this should be a pubfn. Pubfn, let's say load from, maybe let's say from bytes. So we'll take in and take ownership of a vec of u8, and we're going to give back self. This probably is not the best way to do parsing in Rust, but I don't think this is a bad interface. I think this is okay. Now actually, we probably don't want a vec here, right? We don't actually know if we're going to have a vec. We just want to slice. We just want to say there's some data. We have some linear list of unsigned 8-bit data, okay? So how do we do it? Well, we probably want to impl on here, because these are our like bits on the wire types, right? So we'll add a function here. We'll call it from bytes. And it's going to give back a self. This is beautiful. We'll also have a method on this type that we'll call byte size, which is going to give back a usize. How many bytes is this whole structure? Is there a way to test this nicely? Well, I don't know. I think I want to do this manually. I don't think I want Rust to calculate this for me. 2, 4, 6. Then 10 times 2, so 26. I don't know if I trust Rust to calculate this for me. I'm not sure. We also want to be able to write this back to a slice of bytes. That would be useful. And again, maybe we should be taking some kind of like reader and writer interfaces, doing this in a bit more of a Go way, but I think let's just move slices around for now. I think that's okay. If it becomes a problem, like these aren't going to be huge files. If it becomes a problem, if we want to have better performance when we're dealing with gigabytes of binary data, which we're never going to see, then we can tackle that then. Okay, so, sorry, just quick message break. Let me see what's going on in the world. Oh no, it's just this same spammer. I got this weird job offer, and I followed it through even though I knew it was a scam. Like, I messaged them a little, and then I was like, yeah, your business is a scam. Please stop messaging me. And they continue to message me. Refactoring it won't be hard. Yeah, exactly. If I work on a slice of U8s, any other interface will play nice with that basic idea. But yeah, these people keep messaging me. They're like, "Hey, look how much money you could be making." And I'm like, "Stop messaging me." They said they're with a company on LinkedIn, and I've looked up the company on LinkedIn, and it looks like a real company. And I'm thinking of messaging them and just being like, "Hey, do you know? Are these people actually affiliated with you, or are they just using your name? And if do you know that they're doing this? Are you aware that your marketing people are like this? But the whole business might be a scam, so maybe that's a fruitless endeavor. But I'm gonna do it anyway. I'm gonna do it anyway because I like to think I'm gonna right the wrongs in the world. That was another tangent. We're really tangenting hard here. So, we need to get a bunch of data from this now. There's a method. Actually, let me do this the other way. Let me rust up doc. Okay, let me... Annoyingly, I'm having to run Twitch in Firefox. I can't log into Twitch from Chromium anymore. It's blocking me. I don't know if that's a Chromium thing or what. But, so my tab's open on the wrong screen. Maybe that's a good thing. I don't know. U16 from bytes. I think this is a method, right? From LE bytes. Oh yeah, this is the other important part of a binary interface. I forgot to do this. I'm going to write it in red because it's so important. Little endian. Okay? This is really, really important. The little end of the byte goes first. So that means that if we have the number... let me just, I maybe don't need to explain it, but I'm going to write it out quickly anyway. If we have a hexadecimal number, 65FA, it means that then we write that to a file. It means that the first byte will be FA, and the second byte at index 1 will be 65. The little end of the number, the least significant part of the number, is the lower index, right? This is really important to be very explicit about, because if you're not, things will go very wrong. Okay, so from LE bytes. So we can take an array of length 2. So it feels like we might be able to pass subsections of this data around. We just need to verify that we have enough of it left. So how do we do that? Well, first off, let's just refresh ourselves on the interfaces that are available to a slice. std slice, here we go. See also the primitive type. So, subslice. Split. Not quite what I want. Split, split n. Okay, so there's lots of ways to split. And get actually returns an option, interestingly. So, maybe get is actually just a better interface than square brackets, because it's going to give us none if out of bounds. Okay, so actually, when I did an if here, what I can really say, what I should be saying is, if let sum sub data equals self data get this thing. Right, this now then just plays nice with Rust types. So if we can do this, then do all of this stuff, else something else, else return the error. That's more rusty. That's a lot more rusty. That feels good. Little endian, the why does reading this hurt my brain endian? Just format your output better. This is always the key, right? Just format your output better. Once it makes more sense from the computer point of view. Like if I'm reading bytes in order from memory and I have to bit swap them, that's really confusing. If I read 4, index 0, 1, 2, and 3 for a 32-bit number, and then I have to swap them around to get, it makes sense. It makes sense. Can't format with a hex editor. Write your own hex editor. No, I don't know. I do all of this stuff on the terminal, so I think I've gotten used to it. For my PlayStation 2 stuff, I recently rewrote all of my code to output little endian, and it makes it so much easier to debug stuff. And it's also consistent with the Sony docs. Well, no, hold on, that's not true. The Sony docs put the little end on the right-hand side of the page. It's confusing when you're outputting it for human consumption. There's different objectives you have to optimize for. Okay, I'm getting really sidetracked today. It's quite bad, but it's fun. It's all a journey. So we get rid of this. So, okay. I'm glad I worked out that this interface works, and this does the range checking for us. This does the range checking for us. Okay. So the point of this is, we're gonna make a let out. We're gonna make a mutable variable called out, which is gonna be a self with no fields initialized. Explicitly no fields initialized. We have to use those two dots. Those two dots default everything. Then we're gonna say out version equals maybe if let. Oh, this is gonna be a lot of if let. It's okay. If let some version is data dot get. It's the first two bytes, right? So data dot get this. If this is correct, then out dot version is version, and there's going to be a bit of copy paste here. It's going to be a little bit of copy paste here. Okay. Else. Well, actually, it has to return some error, right? It has to be a result. And we'll do string, even though string's gross. So actually, I think what we want to say is out.version equals u16 from, what did I call this? From, whoa. LE bytes. What's from LE? Ah, from LE bytes, okay. From LE bytes. Now there's a problem here, and we'll get to that in a second. Okay, or is it okay or? Oh, I can never remember the names of these functions. It's really bad. Option, which one takes a none and gives us an error? Is it okay or? Yeah, okay or. It converts it into a result. Okay or not enough data to string. And then we question mark it. And then we have to wrap it up. But hold on, the question mark goes in here, and then this goes in here. Now, I bet this fails as well. No, this always succeeds, because it takes an array with two elements. Excellent. This thing is not an array with two elements, so I don't know what we do about that, but we'll cross that bridge in a second. Entry point. Good lord. So this is 2 to 4. And then section, we need to work out how to go from a slice into an array of fixed size. So 4, 5, 6, 7, 8. This has to be like this. There's a stray bracket there. Out.section count is data get 8 to 10. We'll copy and paste because that makes more sense. And then, oh wait, sorry, this needs to be a, hold on, what am I doing? 8 to 10, but we want it to be an integer, so it has to be filled 8 to 10. And then, last but not least, we're gonna have this unused, which is going to be 10 to 16. Beautiful. Beautiful, beautiful. Okay, so we can grab a header from bytes. That's good. So the first thing we're going to do is, this also now has to be a result. With this, it infects everything upwards, but that's good. String. That's what I wanted. We want to know when this fails. We need to have some way of handling, because if we just have like 1 byte in here, then obviously this won't succeed. So it's good that we can make this a result. Let header equals header from bytes. And that's what we do. This is how we do it. This is the power of Rust. We start to put these things together. We have good explicit error handling. We've thought about these conditions. Okay, so for... and then we want to say data. Actually, no, we don't. No, we don't. Do we? Yeah. So the offset of the sections is its header byte size. How many bytes is in the header? And then we can also work out here the data offset, because the data offset is just the sections offset. So where do the sections start plus the size of a section times the number of sections, which is in the header. Cool. So this is where our generic data starts. This is good. This is good to know. This is really good to know. So let's just grab this as a blob. Let's say that our parse sections, like our sections from bytes, like we'll get an array. We'll say sections equals section vec from bytes. We'll send in the data, the slice of the data that goes from sections offset to the end of the file. Can I do an unbounded range here? I don't know if I can. We'll find out. We'll find out. I know I need to give it an n, which is going to be header dot. It's going to be header dot section count, and we need to unwrap this as well. Cool. So we get n sections from bytes, and then we'll also say let data we'll call it tail data, like everything else in the file. That is just data.get data offset data.len. So the rest of the file. Beautiful. No tail data. I guess. Awesome. I think that's good. And you have to have tail data. You can't just have a header. Just a header is not a valid file. If there's no tail data, that's an error. Now, I am going to have to take a very quick breather. I'm just going to go have a stretch, refill my tea, and then I'll be back and we'll get some tests written to load and play with these files. Back in just a moment. All right, we're back. I need to make a more engaging BRB screen. Something fun. Would be good. I saw there's a streamer, when he takes breaks, he runs little like Quake bot matches, which is kind of cool, kind of on brand for me, because I used to be a Quake commentator guy. That would be fun. Maybe I should rig that up in a script. Let people bet on the outcome or something with channel points. That would be cool. All right, so we're getting very close to this point where I've written a bunch of code and I'm getting stressed out that when I hit compile, it's going to yell at me for a bunch of reasons. But we're going to keep pushing through for now. We're going to finish this unimplemented stuff in section, right? Because I've used a couple of functions here. I used this byte size and this vec from byte, so we need to define them. We'll make these private functions for now. I don't think anything outside of here. Well, it's not true actually. People might write better parsers. Anyway. We'll make them private for now and force everyone to use myJank APIs. That's the goal. That is the goal. So we'll say byte size. Typing's hard. And this is just, what did I say? 4, 8, 12. 12 bytes per section header. We're going to have a function called vec from bytes. We're going to work from the top down. Okay? So we're going to write vec from bytes, assuming that we have a function called from bytes. We're going to work from the top down. So again, we're going to have data, which is going to be a slice of U8, and we're going to have n, which is going to be a U16 of the number of sections. It's going to give back a result of vec self, and again, everyone's favorite result value string. Now, for I in n, so we do this n times, we need to make a mutable variable called maybe data head that will move forward, right? We'll take progressively more advanced subslices of data head. We're going to move it towards the goal. Now, mutable, so this is interesting as well because data head, right? This should be a mutable variable that is a ref to a U8, okay? This is different, I hope, to a mutable variable that is a mutable ref to a U8. I think I think this is okay, right? Data head is going to change, but the underlying data is not. I think that's what we're saying here. I might need to be more explicit somehow, but I don't think I need to. I've also never actually seen a mutable slice, but I assume that's a thing that exists. Maybe not. I don't know. Is that a Rust thing? Do people do that? Is it just like bad style by convention? I don't know. Falling down a lot of brain holes today. Okay, so for each thing, all we want to do... Oh, we need an output variable as well. So for each section, we know there's n sections. We've been told there's n sections. We want to grab, we'll call S is section. Let's call it self from bytes, so we don't have to type out the actual name of the struct. Less typing if we refactor the name later. And we're going to get it from data head. And unwrap it. And then all we do is say data head equals data head. We get the sub slice from, now I think I do, maybe I should use get, I don't know, let's just do it with square brackets because I'm lazy. We're going to get it from self byte size. Actually, you know what? I think what's even better is to do it like this. So let's say sub data. We'll make this variable called sub data again. We'll say data.get, because we can just do away with this weird mutable variable entirely, right? We don't need to add something. We don't need to have a head that we add something to and add something to and add something to. We can actually calculate the offset. So we're going from I times self byte size. And that's it. That's it, right? This is the same effect as adding byte size, or taking, adding byte size to kind of add data head every iteration. We start at 0, then we go to, 12, then we go to 24, 36, and we get bytes from there. Sub data. Awesome. Makes things simpler. Now we just need to say okay, or we'll probably format here, and we'll say no data for section I. Beautiful. And that's it. That's all we do. So now we just have to write the next bit, which is from bytes. Which again is just going to get back a result. Self. I forgot to actually return something in that previous function. That's okay. It's very okay because it's a result. From bytes. Okay, so we want to do the same thing as up here, right? We want to do this. It's just going to be a little bit less gross. I'm actually going to copy and paste from this to get started. I think that makes a lot of sense. So we'll let out. We'll just make an empty self with everything default initialized. Do I need to be explicit about that? I don't think I do. They're all just primitive types. So it should be okay. This should be fine. This dot's going to do all my heavy lifting. Now out dot size. Where did I just jumped to this mark. Where did that mark go? How is mark A not set? Because I swear I used it literally 2 seconds ago. Okay, so out dot size is the first two. Let's just reorder this slightly. I think having your smaller types at the top looks nicer. Out dot size is this. Then we have out dot mode, which is going to be the next 2 to 4. Then we're going to have address and file offset, right? The address in memory, now this is a U32, which is a really, this is a big number, So this goes from 4 to 8, and this goes from 8 to 12. Wonderful. Okay, and that's it. And then we just say, okay out. That's all we do. That's all it takes. So, we have, this should be a working parser. The only problem is we don't have a working writer, right? It would be nice to be able to write these things 2 bytes. Now, how we do that? What API do we want for this? Right? We could do it like this and say we have a reference to a self, and we give back a vec u8, right? We can't give back a slice here because what's the slice pointing to? That's not really gonna work. That's not really gonna make much sense. We can't really It's not going to be any good. So we could do it like this. We could also do it like this, where we have, you know, a mutable ref to a vec of u8s, and we write it to it like a data stream, right? We just push to the back of this vector. And I think this might work a little bit better. So none of these, I don't think any of these things can fail. All we say is out.push. Now, the only thing that would be nice, right? Because we have these things that are multiple bytes. It would be nice to be able to say maybe out.extend. Did we see this before? Was it called extend slice? Right? Where we can pass a slice in instead. Slice as slice. No, I don't want an array. I want a vec, sorry. I also need to work out conversion between array and slice. I'm sure there's an unsafe way to do it. Extend from slice, which takes a slice. Yeah, okay, cool, perfect. From slice. So this is what I want, and then I want to say out.version.to LE bytes, I assume. And then I might want to like borrow it, I think. So 2 LE bytes. It gives us back an array. So we'll find out what happens. I'm probably going to get a million type errors because of how I've done this, and I'm just going to keep typing for now, and then we'll work it out later. Except this also then needs to be self instead of out. So it's going to be self.version, self.entrypoint, well, actually, this is even better, self.hardwareconf, because that's already an array. Then we're going to get self.section count, and self.unused, even though it is used. Actually, having the underscore in the name probably just confuses things more because it is actually used now. And that's okay. Cool. So do I might copy and paste the start of this section, so our header can get written out, and our section is also going to get written out. We need a 2 bytes, right? 2 bytes. Okay, extend from slice. We're gonna get out. Maybe I should name it reserved instead of unused. This is fantastic. This is actually exactly what it should be called. Unused made more sense when I was prototyping it and I didn't know what was going on, but now it is, as far as Rust is concerned, used. So yeah, that would be good. That's the correct name. Thank you. I'll do that in a sec. Size, mode, and then it's gonna be address and file offset. Okay, we really need to actually compile this now and see what happens. I'll just do one more thing, just one more thing. just one more. Mutable ref to a self, we'll take out as a mutable vec u8. At least this has a really simple failure mode and really simple borrowing semantics, right? At least this is, there's no like weird borrow checker stuff. So we say, interestingly, oh yeah, so we need to be able to get a header from this. So maybe we need a function for this as well, right? So if we have a self, can we give back a header that corresponds to this self? And we can say header, we can just give it back. We can construct it manually like this, version, entry point, section count is going to be sections, len. What else do we have? We have hardware conf and unused. Hardware conf is going to be 0. It's going to be 4 of them. And I'm going to change this name right now to reserved. And also that should be a colon, not a semicolon. This is good. So unused, everywhere we see this. Nice. And it's good that I kind of preserve it here, right? If I read it in from bytes, then write it back out 2 bytes, even if I don't understand what these fields are, I still read and write them. I still preserve them. And that's an important kind of detail that you have to think of. So we'll say reserved. So there's 10 bytes in here that are currently unused, but we can afford to spare 10 bytes here and there. That's good. So it's important to be able to get a corresponding header from this, because the first thing we're going to do here is say let header equals self.getHeader. Then we say header.to bytes, we pass in this mutable vec. Then we say for s in section, self.sections, we want to s.2 bytes, dump it into this file, and then we want to, well, I guess, maybe we need an alignment check, maybe not. Alignment's not that important. We can deal with loosey-goosey alignment. We want to probably, cool. Okay, we want to just write all the rest of the data. We want to say out.extend s.data, the rest of the file. So we should be able to round trip a file now, and this would be a really good test. Can we load a file, parse it, and then write it out? So maybe the first thing I do to actually consume this is gonna be to make a binary here, vm source bin, and we'll call it bin dump.rs. I think that's a good name. Right, so it'll have a main function. I probably want these to be pub. Yeah, I want these to be pub because I want to be able to, interrogate them. I'll make this pub too. Will I? I don't know. Maybe I just need to be able to format it and like display it as something. I'm just gonna make everything pub for now because I think that's pretty safe. Cool, so I'm gonna borrow again from my files because I can never remember all of this setup. I'm gonna do this, reader. Okay, so we read a bunch of data in, right? Usage, input, beautiful. We decide if we're reading from a file or from standard in. I really like having that as well. Read a file. Okay, except this isn't. We'll just call this bin now instead of program. I think that's a better name. Okay, so we've got a binary. Now, I don't know why this is mutable. Because we read. Oh, sorry. Yeah. Well, that. Because we read into it. Yes, we make a new vector and then we read the. Yep. Sorry. Okay, I'm with it. It has to be mutable. Except now we have to. It's called bin now, not program. Okay, that's good. So we've got a binary. So what I want to say is bin. Right. I wanna do this. Binary file from bytes. And I really need to rewrite these mains. I don't know if they should return results. I don't know if that's good. I don't know if that's a good thing or not. Okay, so we get a binary file from bytes. Then I just want to println some stuff about it. I want to say file. Let's say version. Entry point. Number of sections. We'll just print out the dumb data for now. This is going to be file.version, file.entrypoint, file.section, sections.len. Then maybe 4s in file.sections. So for each section, we'll println. It's gonna be a section. It's gonna what am I doing? It's gonna have the size mode. Yeah, we'll just do 4 numbers. So we'll say size mode offset s.size, s.mode, s.file offset, and s.address. And this is a macro. Cool. And that's it. That's all we do. That's the whole file. Nice. Okay, so what happens? What is gonna happen here? Well, first off, we need to go into our lib.rs and we'll say pub mod bin format. We're not going to pub use it. We're not going to pub use it. We're just going to pub mod it. So we'll say use, no, we're going to say import. No, we're going to say use. Like, what language am I writing? I'm going to copy all of these first off because that's important. And I don't need any of the VM stuff. I've been writing JavaScript. Import is on my brain. Use. So I have to say use simple VM bin format binary file. Oh, except that's the wrong file. Hold on. That's not the bin. Bin dump. This one. Okay, so what happens if I make now? I'm going to have a million errors. That's okay. A couple of semicolons missing. This happens. We're just going to work through all these. We're going to work through all these. There was a copy paste, so that's bad. Again, JavaScript on the brain. JavaScript brain rot. It's confirmed. What else have we got? We've got to have this. Version, header. Does that not work? Oh. What am I doing? There we go. You missed those. Odin made semicolons optional. Yeah, it's hard. Swapping languages is really hard. It's also hard when you're writing a language that has different look and feel to the language you're writing the language in. Cannot find sections because I keep forgetting to say self. What else have we got? S. Can't find an S. S, 2 bytes. This is self, not S. My mistake. Machine, yeah, so we need to import this. We need to say use crate machine. I think this is the only thing we use, right? Oh yeah, and memory map buffer. I really need to clean up the exports. It's a bit gross. Base expression. Can I not empty initialize? Does it have to implement default? I guess I should derive debug and default anyway on these. There's literally no reason not to. Like, they're just primitive types. There's all sorts of things I should probably derive on these. Probably like copy as well, right? Base expression. So can I just say like, I don't know. Oh wait, hold on. So what I actually want to say is default. That makes more sense. Oh yeah, I did that wrong. I did that really wrong. That's okay. That's okay. From Ellie Bytes. Well, glad I copy and pasted that a bunch of times. What was the problem here? From Ellie Bytes. Okay, so Rust convert slice to fixed size array. Is there a way? I don't know if there's a safe way to do it, but we can do it. Slice is an array. Try into. Ooh, that's good. That's really good. Yeah. Into. I didn't even think of into. The literal Rust type system magic. Phenomenal. Okay, so this might have to okay, or it has to be a try into. Yeah, that works. Okay, so we're gonna split this onto 2 lines because this is getting disgusting. So we're gonna go data get 0 to. So we have either some or none, so we can map inside of this. I will say version LE is a U8, a fixed size array with 2 U8s. So we'll map inside, no wait, but map returns a result. Hold on. hold on. So we want to turn this into a, wait, try into returns the result. What does try into return? I'm pretty sure try into returns a result. Try into, where is my scroll bar? Here it is. Try into returns a result. Okay, so I want to okay all this first. So now we have a result. Now I want to chain this with a second result that returns a different error type. How do I do that? Gosh. So result. I mean, first off, what is the error type, right? So what is the error type? Self.error. What's error? Do I have to look at, so this is defined in try into try into. So is this defined on the slice? Yeah, this. What's the error? Try from. Self error. But what's the error type? How do I know what the error type is? Is it just a string? How do I know? I don't know. I'm confused. Let's just see what happens. It's gonna tell me. And then I think is what I want. If I look at result, there's functions for chaining results together. And then. No, that takes a function. I don't want a function. F is, oh, actually, maybe I do. It takes t, it gives back a UE. So no, that's not quite right. A function that takes a t. Oh no, it is. Because this is a U. F is a, no, that's not right. I don't think. Hold on. The result has like a whole list of how to do this. Result explains this all. There's like a table somewhere. Try from slice error. Thank you so much, Bob. Yes, you are absolutely saving my life. Oh god. Okay. But so I need the errors to be the same, but I can't really lift. So the problem, this requires drawing. This is a complicated enough problem to draw, right? I need to maybe add a new page as well. Okay, so, oh my gosh. Let's do that. There we go. Perfect. My layers are a mess. So I have, let me get rid of this thumbnail real quick. Oops. I have, that's distracting me. It's distracting me. So I have a result, and that result is a slice of U8, and then whatever the hell that gives back. What does this give back? Vec get. Wait, is this slice? This is slice get. So slice get. Oh, it's an option, sorry. So I can choose what I put in this error. So I have this. Actually, is there a way to do it? Hold on. What I actually have, there's a step 0 here where I have an option of ref to U8, right? I go to this. I can choose what this error type is. And then I have a function that takes a ref of U8 and gives us back a result of an array of U8 of size 2, maybe a ref to it, I'm not 100% sure, and then whatever this error, this wacky error is, try from slice error. Right? I don't want to have to put the same, I don't want to have to make one of these errors here. That wouldn't make much sense to me. But I think to chain these results together, right, to chain this result to another result, the error types have to match, because otherwise, like, what are you doing? So is there a way I can chain from this directly into that, basically? Is there a way? Well, actually, does this have a default? No. Okay, that's good to know. So option. Is there, let me look at the docs for option. And let's look at the functions that take a result. Map or else. Okay or. Takes an error and gives back a result. That's not what I want. Option. Transpose. Result. Option of result into a result option. That's not what I want. Debug. Yeah, okay. So I've got a Rust. I've got to make a try from slice error. I've got to make a try from slice error. That's what I think I got to do. Unless I somehow lift this up into another function g, which is gonna take a slice of U8 and give us back a res ... x, where x is some nicer type than a try from slice error, right? Where I've kind of wrapped this step up in something that maps the error type, a map error. But that's also awkward in a way. I guess it isn't too bad. Okay, actually, maybe that's what I do. Maybe that's what I do. So it's just a really long line. That's what's kind of making it hard. Yeah, okay, I can transform the try from slice error to a string if I want. The hard thing is that I don't actually have a result. I have a function that maps into that result. So I need to apply that map at the right point, if that makes sense. I guess not though, right? Because I don't know, we'll see. We'll see how this shakes out. We'll see how this shakes out. I need to split this out onto more lines because it is melting my brain. So not enough data, and then, and it must be and then. It must be and then. And then. To continue the computation. Yeah. So, oh, change scene. Thank you. I know some people are here for the art stream, but yeah, we do write code sometimes as well. Good result map. And then. So and then takes back a thing that, yes. So and then, oops. We have a slice of U8. So we'll call this X. And we want to say X.try into. And then we want to map the error. We want to say format E. Well, I guess it's just E.to string, maybe. Cool. And then we question mark that. That's what we do. Now version equals from LE bytes, version LE. Okay, so this adds a lot of lines to this, but that's workable. Is it worth wrapping this up in its own little function? Perhaps. Maybe we just write a little function. Except, nah, we need it to support different sizes. No, I'm going to put it in a function. Okay? I'm going to do it. We'll call it slice to U16. It's going to take data, which is a slice of U8, and it gives us back a U16. We just wrap all this up because we're going to use it quite a few times. Okay, so we'll just call it LE equal this, and then we return U16 from le bytes. Cool. And then we do the same thing for u32, but we need more things. And then I probably also want like a start. Probably want to do this as well. So I don't have to slice and then slice. Oh yeah, it needs to return a result. Sorry, you're killing it today. I'm not. Result u32 string. Yeah, Bobbius MVP in the sidecar. Very important, very important. Okay, so result. So this then has to be an OK. We don't want a semicolon at the end because this is what we're returning. This has to be start and then start plus 4. And then we say OK, u32. Cool. Beautiful, beautiful. Beautiful. I am just gonna... Okay, okay. This looks good, this looks good. This is feeling like the right kind of thing to do, because then all I say is version equals slice to u16. We give it the data, and we give it the start address of that thing. This feels way nicer. This is at 2. This is at, oops, 8. I need some question marks in here. Awesome. Okay, I think that's good. I think that's good. Trying to figure out how to design a parser combinator library for Odin. Yeah, I don't know. I mean, parser combinators are good. If it has good support for like higher order functions, you're probably fine. You're probably fine. Okay, so outsize is slice to u16, add data starting at 0. Mode is this starting at 2, except I need a question mark, not double semicolon. Address 4, except this is now a u32, and that has a file offset, which again is going to be this starting at 8. Okay, let's see how it looks, how it feels about this. Map error. I forgot to actually do a closure. That's okay. It might yell at me about some interfaces here. So try into. Do I need to be explicit about what try into instance we're using? Maybe. I would have thought that was okay. Why can't it work? Hold on. Let me double check what these errors are saying, because there might be another thing. Type must be known. Okay. So it can't work out what I'm trying to try, what try into instance I'm using, but weirdly it comes out in the error. Let's just try doing this. Let's say try from slice error. Is this in the prelude? Try from slice error. No. Weirdly, this appears to actually resolve the issue. I'm not going to import this because I'm not sure this is actually the correct solution long term, and I want it to be ugly. But that literally seems to work. That's kind of crazy. It's kind of crazy. Question mark has incompatible types. Oh, yeah, I need to do this as well. Okay, but okay, or, and then we can do this. If only I could do generics on like an integer, right? Then I could do some cool array stuff here, but we can't. We can't, and that's okay. That's okay. Odin has generics, but they're relatively weak. So basically, you can't do what I've done with my combinators, where you're like, hey, here's a million generic parameters and like stuff like this. You can't do this. This is the interesting one where you're generic on a thing that is generic on other generic parameters. which is why we have this phantom data thing. It's kind of cool. It's kind of fun. It's kind of funky. Okay, so this also needs a try into, but it's going to be a and then try into. And it needs to have this map error. So annoyingly, these fields are still absolutely disgusting to unpack, but it's still a vast improvement on what we had before. I'm just going to copy and paste this line, because I think that is pretty good. Cool. Except it's 10 to 16 here. Okay, beautiful, beautiful. What happens if I run? What happens if I build? What do we get? Try into expected infallible. Expected infallible? What? What does that mean? Oh, no? Huh? What? I don't know what this error means. Huh? 36. Expected infallible. Trait bounds. Try from. U16. Oh, hold on. That makes sense. What if I do this the stupid way and just double everything? Wait, am I treating this like they're bytes anyway? 1, 2, 3, 4. I am. Maybe these only need to be bytes. Let's make this 12. Let's make this bigger. 10 to 12, so that'll go to 22. Infallible's an error for a result T that can't actually fail. That's interesting. That's kind of cool. Okay, here we go. Reserved. There we go. Self byte size, expected U16, found U size. Now, as U16, as U size, byte size. So this needs to be I as U size. I guess we just quietly do that conversion. That's okay. Expected a slice of U8, found just a U8. That's a bit weird. From byte subdata. Subdata is data.get. Hold on. Something weird happened here. There's something's going on. So get I. So we actually want we want to calculate the size a little differently. Let's say the section start is I as U size times self byte size. And then the section end is going to be section end is going to be section start plus the size of another section. So what we're actually getting, I guess this dot dot didn't hack it. Section start. And it's actually the section header, start and end. We should maybe be a little bit more precise here, but we'll survive. We're not using this anywhere. We're not saying out.push. We're never pushing this thing. So thanks Rust for finding an unused variable. Very, very useful. Expected U16, found U size. We're just gonna cast this down. That might panic. It's okay. If you have that many things, it's your problems. Try into is guaranteed to work. Still has to return a result here. Yeah, that's cool. So it's for when you have a trait, but the thing implementing that trait doesn't actually need an error. That's cool. That's cool. That makes sense. Okay. Reserved. We need to make this a little bigger. Hardware conf. We need to make this a little. I think 8's okay. Okay, again we have this issue where we need to cast as U size. Expected UA. Okay, now we have this fun thing where we didn't get a borrow. So do I just borrow it? Cool. From bytes. Found nothing. So from bytes forgot to return anything, and that is also really common. Oh yeah, wow, I really forgot to return anything. Binary file. So version is going to be the header version. The entry point is going to be the header entry point. The sections are going to be the sections that we've got there. And the data is going to be the tail data. Beautiful. We never unwrapped this for some reason. And I guess this also then needs to be to_vec. And we own it. This is as. Okay, self.sections moved. I guess we can do this. Self.data, we extend it. That is also okay when we're converting it to bytes. Can I just clone? I can just clone. And again, that makes sense. We have to copy, right? We can't just refer to someone else's data. We need to copy it out into the binary that we're writing. Okay, section.size, expected U32 found. That is interesting. U32 plus U16 isn't defined. Okay, so file offset plus section size. Let's put this on its own line. Maybe, actually no, let's not. Let's just do the dumb thing. Let's just upcast it. Okay, now this has to be a U size. So, what if I, let's say, let's get this as a U size and then let file and, which is going to be file offset start plus section dot size as U size, right? What's section dot size? Oh yeah, the size of the actual section. That makes sense. Okay, so then we go file offset start dot file offset end. Nice. Now we have everything nicely as a U size, which is good. Expected U size found U32. Where? Section address, section size. Okay. So these need to be... I really need to make these more sensible types under the hood, and I will do that at some point and deal with all of the refactoring. The longer I leave it, the worse it'll be, but that is okay. This has to be in a box. Because of how it's an interface, it needs to be in a box. Okay, section file offset plus section size as U32, we don't really care. Okay, expected result string found nothing. We just need to say okay at the end here. What else have we got? Give me something else, give me something else. Length is a private field. Yep, that also makes sense. What else do we see here? Mismatched types, weird. Expected result, we didn't get one, so let's say okay. Okay, nice. We did it. We did it. What an ordeal. We did it. How do I actually build one of these now? Well, I didn't think about this. I didn't think about how I'd actually build this file. And I might actually have to leave it there for today, sadly. It's been an hour and a half. We have defined a binary file format. It's been pretty productive. Next time I'm going to come back, I'm going to test it. We're going to start writing binaries out in this format. We have a nice little utility that will dump them. This is a real sidetrack from string, but it's actually going to be really important to strings. It's going to make strings so much nicer. Okay, this is fun. Thank you very much for tuning in. It's been good. I'll deal with this git soup in a minute. Thank you so much for watching. My name's Tom, and I'll catch you next time. Bye.